Okay, sometimes we want to change the look of a fractional value if it contains a radical. Uh, we could have a radical in the numerator and we could have a radical in the denominator. Sometimes we have a radical in both. What we want to do is be able to rationalize. All right, rationalizing is just a fancy term for saying that we're taking something that's radical and making it not radical. All right, but it's not like you can make it disappear completely. We're just moving it from one part of the fraction to the other. So in the case of number 10, all we're really doing is getting rid of the radical that's in the top of the fraction, but in doing so, we're going to put it in the bottom. All right, so we do that by multiplying by whatever the radical value is. In this case, it's radical 2, but we do that top and bottom. All right, because this fraction is going to be equivalent to 1. And anytime you multiply by 1, you're not really changing the value of an expression. All right, so if I'm going to multiply fractions, what I'm going to do is I'm going to multiply the top by the top and the bottom by the bottom. So I'm going to be looking at radical 2 times radical 2, which is radical 4. And then 2 times radical 2, which is just 2 times radical 2. Because like I said in the last video, you can multiply radicals, you can multiply regular numbers, you just can't mix the two. All right. The square root of 4 is a known value, that's equal to 2. So we have 2 over 2 radical 2. But we also have a common 2. 2 divided by 2 is equal to 1. So I'm looking at 1 divided by radical 2. So in the original problem, we had radical 2 in the top and an ordinary number in the bottom. Here we now have an ordinary number in the top and the radical value in the bottom. All right. We could also rationalize the denominator, which is the same process. You're multiplying by the radical. Oh, that zoom thing keeps popping up. I'll have to change the setting there. So multiply top and bottom by radical 2. Multiply the tops. 2 times radical 2 is 2 radical 2. Radical 2 times radical 2 is radical 4. You could skip that step because radical 4 is 2. So there's a lot of stuff here that you can kind of get away with doing in your head. The result here is just going to be radical 2. All right, so it kind of begs the question of, well, why would we need to do this? It all depends. In the case of number 11, I don't want to say I think it's obvious, but I hope you'll believe me when I say that the radical 2 that we got as an answer is a simpler looking expression than the 2 over radical 2 that was the question. All right. In the case of number 10, you can go either way. You can look at it and say, well, I don't think it's any more or less complicated than what we started with. But then somebody else would be like, well, we got rid of a 2 and made it a 1, so maybe that's a good thing. Right? But if we needed to do something with this, that would kind of dictate what form would be more useful. All right. So number 12, very much along the same lines. Multiply top and bottom by radical 3. Top by top. So 1 times radical 3 is 1 radical 3 or just radical 3. Radical 3 times radical 3 is radical 9. But square root of 9 is 3. All right. Number 13 is the first instance where we're kind of mixing concepts together. We have a radical 12. That radical 12 could be broken up into the square root of 4 times the square root of 3. All right, square root of 4 is 2. So we're looking at 2 radical 3 over 2. Now those 2's cancel to equal a 1. So this is the same as saying radical 3, which is wonderful. But we didn't do what they asked us to do. I mean, we did part of it. We simplified, but we didn't simplify and move the radical from one part of the fraction to the other. All right, so I now need to rationalize this. So I'm going to multiply top and bottom. Let me change the color up here. I'm going to go, oh, okay, purple. Yeah, that sounds good. So I'm going to multiply top and bottom by the radical 3. Radical 3 times radical 3 is radical 9 over radical 3. So 3 over radical 3. And again, it's the same idea as before. Is what's simpler? You know, you might look at that and say, well, that radical 3 was looking a lot nicer, but you know, we don't know what we need this for yet. So it's all up in the air, basically. So 14, 15, 16 are all along the same idea, or same line, so I'm going to put stars on those. Give those a shot. 17 I wanted to take you through because it's in a different form. It's radical entire fraction, but it's actually a lot simpler because that radical of the fraction is really a fraction of the radicals. The radical 7 I can't break up. I can't simplify, but the radical 8 I can. Square root of 4, square root of 2. So this is really the square root of 7 over the square root of 4 is 2, radical 2. All right. So now we're kind of in a little bit of a bind because the question said move from one part of the fraction to the other. All right. So it's not really, I guess it's not a bind. It's just, it's implied that we have more work to do than normal, than we normally would. And that is because what it's implying in the directions is that the radical 7 has to get moved, and so does the radical 2. So that's what we're going to do. I'm going to multiply top and bottom by radical 2. That'll account for this guy. And then I'm going to multiply top and bottom by radical 7. All right. Really, the whole purpose behind all of these kind of questions is for you to learn the skills associated with working with radicals. We really haven't established any purpose for it yet. And so when people say that you can't have radicals in the bottom of a fraction, they either don't know what they're talking about or they're just making it up and hoping you believe it, because it's perfectly okay to have a radical in any part of a fraction. It's just sometimes you want to move it from one part to another to make your life a little bit more convenient. All right? So, yeah, I mean, that's really all there is to it. So what I'm going to do here is I'm going to multiply, but I'm not going to multiply. So I'm going to write it as radical 2, or radical 7, radical 2, radical 7. 2 times radical 2 times another radical 2 times a radical 7. We use a highlighter. So these two can get multiplied together. And these two can get multiplied together. So I'm going to have a radical 2 on the top, but radical 7 times radical 7 is radical 49, which is 7. So 7 radical 2. You know, if you're ever in doubt of something, just put it in your calculator and see what it gives you. You know, most of the time, it's going to flat out give you something that's reasonable. Radical 2 times radical 2 is radical 4, which is 2, times the 2 that's already there is going to give you a 4. And we have that radical 7 that we're stuck with. All right, so this one was obviously the most challenging out of all of them, but only because of the directions. You know, if it said rationalize the denominator, rationalize the numerator, that would be one thing. But here it's saying move the radicals from one part of the fraction to the other. That's always going to make things a little dicier. And